Hello guys, good evening. Hope you all doing well. Myself is Deepali Pawar. Here is the other project presentation which are conducted by 360DigiTMG. Our project title is Cost Prediction in EdTech Industry. Next slide please. This project completed under the guidance of Mr. Sharad Chandra and Mr. Bharat. Next slide. Here is our group member who are conducting presentation one by one. Harish Penpale, Nilesh Penpale, Vaibhav Parinche and Saili Sadunke. Next slide. Here is the list of project content which are going to represent here. Project objective and constraints, CRISP MLQ object methodology, technical stacks, project architecture, data understanding, data pre-processing, model building, deployment, and conclusion. Next slide, please. Project goal. It contains a goal and obstacle of project. Here is the in 21st century, if we want to sustain here, we have to provide reasonable prices with attractive features to predict the cost of upcoming new courses in EdTech domain. We have to maximize the quality of product and minimize the expenditure. Constraint. Here is the main constraint in resistance to change, shortage of accurate statistical data, and imbalance or unbiased data. Next slide, please. Here is the CRISP MLQ methodology. There are 6 phases in the CRISP MLQ methodology. First phase is business and data understanding. In that phase, business objective and constraints are involved. We are used to optimize the terms like maxima and minima about the project. In this project, we are going to maximize the customer with increasing annual profit and minimizing the churn rate of customers and expenditure. In data understanding, data present in categorical and numerical format. Next phase is data pre-processing. In this phase, we are going to clean and filter the data as per our requirement. For applying the model building, we are going to apply EDA technique like dropping irrelevant column, imputation method, outlier treatment, duplication, and creating dummies using one-hot encoding. Next phase is model building. In this phase, we are using some regression method like linear regression, lasso regression, ridge regression, ADA-boost regression, gradient boost regression, XG-boost regression, and also KNN method, decision tree method, extra tree method, SVM, stacking, voting, and random forest. Next phase is testing and evaluation. After applying ML algorithm, we evaluate model with high value of R² and minimum MAE value after testing the model. Next phase is model deployment. In this phase, we deploy the model using Streamlit with Heroku. Next phase is and last phase is monitoring and maintenance. In this phase, update the system, degradation of performance, hardware are the concept of that piece. Thank you for giving me opportunity to explain my views regarding the project. Next presentation will be carried by my friend Vaibhav.
Okay, thank you, Deepali. So here you can see the technical stacks. So mainly here we used the Python as the Python programming language. In that Spider and PyCharm is used as a IDE. IDE stands for Integrated Development Environment. So So Tableau is used for the better visualization purpose, and by using Streamlit, we deploy the model on the Heroku websites. So you can see the whole data pipeline of our projects according to our business. Maximize the quality and minimize the cost, means expenditure. So we collect the data in that format. So collected data is in the primary format by using the survey form. We collected the data. In data understanding stage, we know about the mostly our data is in the discrete form. Only few features are in the continuous format. So by using the Seaborn, Matplotlib, and for better visualization purpose, we extra use the Tableau. So in the EDA process, first moment business decision means central tendency, then dispersion, kurtosis, and skewness. We measure all the values. And the data pre-processing process, for the null values purpose, we use the imputation, in which mean, mode, median according to the features, means deriving the column, and according to that we use the imputation technique. And for the converting the uh, categorical value into the numerical value, we use the one hot encoding. And for here in our project, we use the log transformation. So for converting our data into normalization form. So while collecting the data, we get this some extreme values, which is a apex on the mean and median value. So by using outlier treatment, some values are removed and some are retained. So in feature engineering, we did a backward selection methods. Means firstly we consider the all features, and further that selected the only these features, which uh, means after that our model gives the best performance. So after cleaning the all data in the format, so we move to the further stage of model building. So in model building, mainly scikit-learn main library is used. So here is our target variable is continuous. So use the regression technique. And according to that, splitted the data into train and test. Here we use the 80-20% of the splitting. So totally our model is builded, means trained on the training data, and by using the testing data, selected the best model. Means here we check the coefficient of determination and mean absolute error. And after finding the best model, so now our model is ready for the real-time use. So in that case, we deploy the model on the Heroku website by using Streamlit and the GitHub repository. And after real-time uses, here we also got this much more data. So we have to need to collect the data for the further future engineering purpose. So this is the data collection and understanding. So my friend Harish will be explaining this slide.
Thank you, Vaibhav. Now, we discuss about the data collection and understanding of our project. Now, for a data collection, we are conducted survey. We asked some questions to students with help of Google Form based upon their answers. We prepared our data set. As we used a Google Form, our data source is primary data source. The data collection from a primary source. The dataset is a survey questionnaire filled by college students with the help of survey form on social media platforms like WhatsApp, Facebook, etc. The dataset has 290 records and 17 features. The data collected is in the raw format and is required to be pre-processed. Next slide, please. Data information. The information about our data. We asked some questions to students in survey like name of institute, course, etc. and gathered some features based upon questions and answers. Just like a feature name like institute, course, category, mode, level, duration in hours, country, city, certification provided, practice assignments, doubt session available in course, internship provided, placement assistance, rating of course, recorded videos, training grade, and price of course. Next slide, please. Data types. Now, this is our data dictionary. We categorize data in discrete, continuous, subcategory as nominal, ordinal, and binary. Feature name like institute, course, categories, mode and level, duration in hour, but a particular features like duration in hour, rating, and price we choose because it is continuous data types. And subcategories of data types like nominal, ordinal, and binary, and ratio also. The perfect is ratio subcategory of data type. Next slide, please. Now, next slide is discussed by my friend Nilesh.
Good evening to all of you. As the previous part discussed by Harish, Vaibhav, and Dipali, now we are moving further for data understanding or experimental data analysis, that is EDA. As Harish told you that we collected the data from conducting a survey using Google Form on social media. So based upon the data, whatever the response we have gathered from our students, we prepared our analysis. So there are trainer grades. We have asked for student for high, medium, and low option. So there are 91% of the student wants trainer grade should be high, means the trainer should be expert in his own field, while 8% while the medium, while least or for low. Now similarly for a level of module, means this based upon the prior knowledge of a student on a particular domain. There are around 40% are the beginners, means just want to join the course, while 16% are intermediate, means they have some little bit knowledge or background knowledge of a particular topic, while 43% are the advanced. Next slide, please. Similarly, mode of class, this means in which mode student wants to join the class, whether online, offline, or both. So there are 73% of the student wants willingness to join this course in online method, while 12% on offline, while 15% of the students are convenient in both online and offline batch. Similarly, for placement assistance, there are around 69% of the student wants placement assistance from the course provider, and provided recorded videos. In this segment, there are 93% of the student wants access for the recorded videos. Based upon the pre-processing analysis or performing analysis, we got this histogram plot for a price. As in while working, there are around 3 columns we got in an integer format, that is price, duration of hours, and course rating, while others are the nominal or often nominal categories. Now, after performing the analysis, as we can see, there's a histogram in front of you, which is a rightly skewed data. This means the mean value is more than the median, than the mode. And while performing the analysis, we got a skewness is around 2.2. That is a skew, that is positively skewed data. Now we can see while moving further, that is outlier treatment. Now we can see in a course duration hours, courses are rise from 0 hour to around 1 lakh hours. So we have to perform the analysis outlier treatment by using trimming method, in which we managed in the range around 0 to 250 hours. As we can see in front of you, that is in the left part, this is the plot before outlier treatment, and the right part is after the outlier treatment. Next, please. Now, similarly, on a price, there are around 19 outliers in the price segment. We can see that the one course is around 3,50,000 rupees, and it ranges between 0 to 3,50,000. After performing the outlier treatment by using trimming, we managed to get in the range of 0 to 1,20,000 rupees. Next slide, please. Now, here's a part of a transformation. As we can see, this plot of a price. In this plot, we can see clearly that the distribution of a data is not as much good as normally distributed. While in the right, after performing the logarithmic transformation, we got a better normally distributed graph in front of you. We tried for square root and cube root, but comparing square root, cube root, and the logarithmic, we got a good normal distributed data for a logarithm. Next, please. Now, for a pre-processing, missing values or a NA value treatment. As we collected a data from a survey, there are some missing values are present in our data. So to So we have replaced those values by using mean and median imputation for numerical data, while mode imputation for nominal data. Dropping columns, we have to drop some columns which are insignificant for us. Like there are around, Harish told you that there are 292 rows are there and 17 columns are there. So while performing the analysis, we got an intimation that category and the rating part. Now, this is we have to drop the columns. In case of a rating, we got a correlation around 20%. That is a weak. So we dropped that column, and similarly, category in a nominal data type. Now, outlier treatment, as we discussed it previously, that for an price and duration hours, we perform outlier treatment by using trimming method, in which we got a price in the range of 0 to 1,20,000 and duration is from 0 to 250 hours. One-hot encoding. This is used to convert a categorical data into the numerical form by using a by performing one-hot encoding on. Thank you. Next slide will be represented by my friend Vaibhav.
After cleaning the all data, we further move for the next stage of model building. So in the model building stage, we mainly use the supervisor method. And here we will do some regression techniques and some ensemble models. And for that, splitted the data into training and test. Here you can see. So there is a number of algorithms we use. So linear regression, lasso regression, ridge regression, k-nearest neighbor, decision tree, random forest, support vector machine, extra trees, ADA boost, gradient boost, XG boost, voting regressor, and stacking regressor. So after checking the all algorithms, we find out, noted down the R-square value, mean absolute value, error value, and here we can see the mostly in the k-nearest neighbor and linear regression, we got the least R-square value, means coefficient of determination. But in the extra trees value, we get the highest coefficient of determination among this all model. So for the further calculation, we selected the extra trees is our the best model. Here you can see the screenshot of our Python console. So in the model tuning technique, we use the means defining the maximum number of features according to the 15, and decided the extra tree is our best model. So in the next, after deciding the best model, then next stage is model deployment. Here is the all pipeline of the architecture of the model deployment part. So in the model deployment folder, we require the git ignore files, means all the files you can see, and by using the PyCharm is mainly used the IDE for Python, and with the help of Streamlit library, by on the Heroku website, we deployed our model by using the GitHub repository. So there is a few requirements you can see. So mainly we're facing the main issue of the scikit-learn version. So here the scikit-learn version is 1.1.1. So here you can see the screenshot of our output. So select the institute name, course name, what is the mode of student you want, online, offline, or both. We can see the further explanation in the next video. So here is the video. So this is on Heroku website. Firstly, select the institute, then mode of class. Trainers grade, city, country, according to that internship provided or not, provided recorded videos or not. So here you can see our model is predicted the cost, and this is we also checked on the internet or browsing, this predicts a accurate cost. So, so in the EdTech industry, there is few challenges. The next slide will be explained by my friend Harish.
Thank you, Vaibhav. Now these are challenges we are facing in the EdTech industry. We have to overcome these challenges. The resistance to change, as this is the new emerging technique. Both students and parents are habitual to offline education system, blackboard methodology of learning. Second one is data collection and security. Then limited budgets, the gap between academic and industry. The gap between academic and industries, such like means face-to-face problem solving, delivering lectures and grasping of student in physical education environment. Lack of professional training, poor network infrastructure. Like some students cannot afford a smartphone. There is a lack of connectivity for internet platforms. Adaptability of software and hardware. Next slide, please. Future scope, optimum utilization of leisure hours, government's digital initiative to promote e-learning. Just like one of the institute of government organization is Atal Tinkering Laboratories in school across country with and aim to foster creativity, curiosity, and imagination in young children. Improved teacher and parent communication, enhance visualization, and improve interactivity. Measure success and automating grading systems. Next slide, present my friend Deepali.
Conclusion. Thank you, Harish. After doing this project, what we learned from this project is also main thing for us. From this project, we came to know it is an integral part of student thinking as they make personal and social decisions. It provides a conceptual framework for the examination of the course cost in relation to the relative factors of them. It also provides mean of assessing the current demand and supply situation. This cost prediction frame in the term of requirements and needs of the student, which is most important to survive in competitive world. It will serve useful practical purpose for the educational planning. Thank you. Thank you for giving me your valuable time.
If anyone have any question, please ask. Okay, thank you.